And the next talk is by Klaas Mertens, who is the Global Solution Architect in Equinix. And yeah, welcome Klaas, and he will talk about how to drive impact and scale with the data, big data and AI applications.
Might we wait 5 minutes because it's scheduled for 16:50, or shall we just carry on?
I don't know. Yeah. Shall we start, or? Yeah, maybe we start, so you can take a bit longer time if you like.
Okay, so I think I need to use the microphones here. That's best, so I can't move away. Yes, thank you very much. Heartily welcome and good afternoon from me, from Equinix. And I want to talk about something that maybe some of you or most of you are not really having in your minds when you're thinking about big data, and that is maybe predominantly the question of like how big is actually big data, and is this even an issue? So when we talk about analytics and when we talk about any kind of applications we're using, we had the example just before from the lady from Deutsche Bahn who's trying to build a Google Maps for railway infrastructure. So there's a lot of pictures, there's a lot of data need to be integrated and need to be used to make actually an application out of that. And the question is, had any one of you already ever thought about how big your data actually is that you're using? So can you maybe, from the audience, give me some figures what you think when you talk about big data? What would you consider be a big data deployment in terms of just size, data size? Is gigabyte already big data? Is it terabytes? Is it petabytes? Is anyone even aware about the difference between gigabytes, terabytes, and petabytes? So if I ask this question, maybe. But okay, then I take it from a different perspective. But if you just think about like your standard laptop, probably your standard laptop hard drive has about 1 terabyte of capacity. Is that already big data? Depends, probably. I'm not sure. But you're always carrying around your laptop, right? It's not very difficult. You have a lot of data always with you, probably, even maybe on your phone. But have you ever thought about transporting data and how you do that? I want to introduce you to somebody. This is Lieselotte. She was named that by my girlfriend because it's a very friendly pigeon which visited us last year in our summer holidays. Do you have any idea what Lieselotte might have to do with big data? You don't need to be shy.
It carries a small solid state.
That's very good, actually. I mean, Lieselotte, as you can say, she has a ring on her leg. She's a carrier pigeon. So she's one of the most ancient means of communication, probably, right? Probably something. I mean, is any one of you using carrier pigeons nowadays? Not really? Anyone has experience with carrier pigeons? Actually, very sad story. We can talk about that later in the networking session. But if you're interested, and I mean, it's actually the fastest way to transport medium-sized data or even large-sized data over medium distances. Lieselotte, if you put a small SSD on her leg, is much faster than any fiber circuit that you can find. If she transports 1 terabyte, she's faster over 150 kilometers than any fiber. Anyone doesn't believe me? You can read it up. There's standards for it, if it works here. RFC 1149 IP over even carriers. It's actually an internet standard, and somebody has tried it out. It works. Joking aside, I mean, why I'm talking about carrier pigeons when talking about big data? There are actually use cases where Lieselotte could be of help for big data innovations. Because if you think about some ventures, like there are people who are developing crop science goods in the Amazonas Delta. So they are kind of using new technologies to bring up new crop, and they do that very far away from civilization because there is no interference. And they generate a lot of data on these agricultural farms, terabytes per day, but there is no connectivity. They can't really do anything without it, and they also don't have a data center on the farm to actually operate the data and do anything with it. So what they do is they're using the modern form of Lieselotte, which looks like this, and fly out the data every week to where it can be analyzed. So there is actually a use case and a need for carrier pigeons even in the modern world. Well, taking that back to big data, what I want to talk about a little bit today is about the probably very well-known concept of data gravity. So data, when you use it, exerts gravity and comes to that when you put data somewhere, it most likely will come to that you put more data into the same place. And if you want to do something with the data, then you need to bring in the applications and algorithms to the data to actually make use of it. Like when you want to analyze a huge amount of data with AI analytics, then most probably you need to bring the algorithms to where the data actually is. Because of what I would call the Lieselotte principle, you can't just easily move the data to where the algorithm is, but you can move the algorithm. And that means that whenever you put data somewhere, it tries to attract more data, and it also attracts the algorithms and services that this data needs to be worked at. So what I'm basically talking about is data localization. Has any one of you ever thought about where most of the big data that is analyzed today in Germany actually lies, just physically? What would you guess? Where is probably most of the data you are working with every day from a geographic standpoint in Germany? I mean, okay, yes, but in Germany, if you think about data being in Germany, where it probably is? Well, it's probably in Frankfurt, because that's where most of the clouds are. That's the data location, that's the point of data gravity. Now, there is another concept if you really want to make use of the data, and that's also probably something you have been talking about today as well, and that is the concept of data sharing and making more use of data through different sources. The colleague just before also talked about data sources where he connects brand information into his software and analyzes the data. So there's definitely a need to share the data and to exchange it between different players. And in order to do so, what you need to do is something we call interconnection. So you need to connect data sources together, right? You need to do that to foster more innovation, to have a co-development with your partners, to actually invent new products and services, because you can collect a lot of data for yourself in your company, but if you don't exchange it with others, if you don't bring in more data sources, then probably this data might not be useful. And this data might be lying physically, just from the pure amount of where the data is, on different infrastructures. When you use big data and AI services nowadays, in any shape or form, whatever software you use, how do you usually get to your data? What do you use? What kind of software you're using probably? Who's using a browser for that? Internet browser for accessing applications? That's only a very few. I think it's a little bit more than just have showed up. So what you're doing is you're using the internet every day for using this big data and AI analytics platforms. If you put it in the cloud, you're using the internet. If you're utilizing any kind of software, you put it in the internet. And the internet, if you really think about it, who has any idea of what the term internet actually means? It's interesting. So many people using, yeah? Exactly. It's an interconnected network. That means that is already the first part of what we talk about as interconnection. When you need to bring data together from different sources, be it from the social media chain, be it from online marketing, be it from like Google Maps, weather service, whatever, you're utilizing this interconnected chain and federated networks. But nobody really is thinking about usually how does this infrastructure actually work. There's a lot of talk about gigabit connectivity to the homes and so on, but most of the people are not thinking about that this infrastructure is definitely needed for any kind of big data and AI deployment. And if you look at it a little bit more closer, then you will recognize, and again we're coming back to Lieselotte here, that whenever you're using that, there's an awful lot of physics involved. I was just talking about like where is most of the data sources in Germany currently located geographically, which is what I said, Frankfurt. Why is that so? Why is all of the clouds, all of the service providers concentrating in the Frankfurt area? I mean, we're in Berlin here, and probably most people working with big data and AI algorithms will be located here. But the data they're actually working on most probably is in Frankfurt. And the main reason for that is physics. Because even nowadays, if you go past a certain amount of fiber lengths of distance between data sources, the transport of the data, the cost of transport and the economics goes up the scale and is really not economical. There is a fiber distance still of about 40 kilometers in range from a source of data where it's most economically to connect to this data. That is the reason why all the cloud providers infrastructure in Germany currently is located in Frankfurt. And it's very similar in other places of the world. Most of the cloud infrastructure in the US is located in Washington, Virginia, actually, so in Ashburn. And this is basically very similar to a harbor or an airport. When you come to somewhere with your goods and services where many other people already are, it tends to that you're bringing together more of the different services. Why is Hamburg Harbor so successful? Because there's a lot of ships coming in and there's a lot of goods exchanged at that location. So if you want to sell or buy goods, then you naturally go to this location. Why does the company like KPMG put up an office next to Frankfurt Airport? Because for them it's very easy to get their consultants back and forth in the world when they're directly at the airport. And that's the same thing with the internet infrastructure and with the cloud infrastructure. It all starts to concentrate in one specific location. And in Germany, that is Frankfurt. That's why we have the discussion why there's so many data centers built in Frankfurt. Now, if we put that back to big data and about the need of getting into multiple data sources or need to get access to multiple data sources, and if we also think about that the amount of data is ever growing. We had the example before from Deutsche Bahn when they want to build a complete digital twin of their infrastructure with videos and 3D point clouds and everything. They have a huge amount of data. It's really in the petabytes, and it's not easy to exchange if you want to get access to it. So you need to have the connectivity. Nowadays, with all the tests and with all the services we currently use, we're using the internet and we're using the infrastructure that is already there. And I've just put an example here. You maybe have some data lying in the Oracle cloud and you want to access it from an Amazon instance because that's where maybe you're hosting your algorithms. And you can never be sure what the latency is, how much bandwidth you have between these infrastructures because it's on the best effort internet. It usually works very well in our standard ways and in the standard world we're using today. So if you watch a Netflix movie, it's exactly the same infrastructure and it works very well. But if you start building an application on it, if you want to really make business value out of it, if you maybe build your business model on such an infrastructure where you need to communicate between different sources, then this maybe is not such a good idea and you might be looking for different options there. And there are different options. So wherever you put your data infrastructure, there's always the option to directly connect to it, to get a direct connection on the infrastructure level. Not only on the software level, but to get the infrastructure you need to actually run with huge scale big data and AI infrastructures. And when we from Equinix think about what the future will be from our perspective, we would also think that the world should be something where also the infrastructure, not only the data sources, can be assembled in minutes, on demand, anywhere from an ecosystem of providers, just as you want to envision a world where you can access as many data sources as possible in minutes, on demand, anywhere from whatever source you're deploying. And that is something which currently in the standard ways of connectivity and infrastructure we have is not that easy to achieve. Because the internet, what we are all using usually, is a public network. It's best effort. It's just like it is always there, it's always working, but maybe not, or maybe not to your quality needs. So there are ways to change it, and I just brought an example here that, for example, you can very easily interconnect two clouds in a software layer by just bringing up a dedicated private network connectivity between a data source and a data sink without the need of the public internet, without any hassles you have there on a software-defined way with tools. Maybe some of you know when you're working in the infrastructure world with Terraform providers and stuff like that. So you can very easily integrate different data sources on the infrastructure if you have a software-based layer even for that. And that is something what Equinix is doing on a global scale. So basically, whenever you're using infrastructure or connectivity from the internet, then actually your data, what you're using, is probably running through an Equinix data center, because that's what we do. We operate the infrastructure and data centers of all the location where all the traffic and data is exchanged in the world. We are kind of the Fraports of the digital infrastructure, so we are operating the physical services. And that is something which I maybe would like you to think about when deploying big data analytics platforms, is like where to locate the data, purely physically, not only from the infrastructure perspective, but also to think about where to deploy it, also to have the option to be the sovereign of your own data. Because currently most of the people are talking about like, yeah, when I have data somewhere, I put it in the cloud, and they choose the cloud provider of their choice, right? Google, Amazon, Microsoft, Jonas, SAP, you name it. Or you put it in your own infrastructure. And as long as you're kind of monolithic in your own world, in your own domain, it's pretty easy because you control everything. But once you start building up systems where you exchange data with other players, you probably have to think about the infrastructure below as well. Because if your partner you want to get data with puts his data into Google and you have it on your own platform, it might not work as easy as you think, taking security considerations and everything aside even. So there is a lot of different initiatives going on currently that try to make it happen that you can more easily exchange data between different sources, and that you can actually bring data marketplaces to being. So there is also some examples we had with certain vendors, for example, in the airline industry, where we put up a data marketplace for airline engine data, which was put on such a highly interconnected platform that all the other airlines and all the other partners in this ecosystem could easily access this data without any need of cloud egress cost and high internet bandwidth, because they can all come to this one place, deploy their infrastructure or deploy their algorithms and make use of the data. That is some of the examples that we are seeing in this world of data marketplaces and the actual location. And there's one other thought I just want to bring here to the audience, and that is also that we probably need also to think about in the future of different ways on how to access data. Not only about like how do we access it from a security standpoint, do we have logins, do we have the right APIs, but also where to reach the data. If you want to have a data exchange very much in the past with like your relatives maybe in the first eras of the telephony network, then you had to call the switchboard and tell, well, I want to talk to Tante Elke, please connect me to Tante Elke, and the switchboard did so. And then we had self-dialing telephony where you just dialed the telephone number for Tante Elke and you reached her, and it was very easy. Now we have internet and we can reach anyone in the whole world just based on an IP number. And you probably think about, yeah, we can reach all data sources in the world just based on their IP number or API interface or whatever. But if you think about real big data innovation and really making use of huge data sets and you want to connect to that, then probably you need to think about different ways of connecting to the data also from the infrastructure level. Because in the end, even your big data deployment, wherever you put it, it's hard drives, it's SSDs, and it's cables and switches and network and all the infrastructure beyond. And it's done by cables maybe when you do it on your own in your own data center. It's on a virtual switched infrastructure when you do it in the cloud. But if you need to have this connectivity somewhere, then you need to think about how to get to this data, how to provide the right infrastructure to actually make use of it in a large-scale environment. And that is something what probably also initiatives like Gaia-X and others want to build up. They want not only to build up the data layer and the applications on top and how the data talks to each other, but they also think about the infrastructure below, and the way of interconnecting the various services and sources in this ecosystem to bring together the data to enable you to make more use not only of your data, but also of the data of your partners in your ecosystem or your vendors or wherever you get data from. And what maybe is something we need to think about is kind of yellow pages for data analytics. So something where we have catalogs of data we can use, where we can see what data is available in a European, in a national, or in even a global context, which we can select and which we can also easily connect to make use of the data, so that we don't need to send a carrier pigeon to someone with an SSD attached to his leg to bring me the data that I need to analyze for whatever application I might need. And with that, I want to end. I would thank you very much for your time and for your interest. I don't know whether we have time for some questions. I think I used up the time pretty well. So
We actually do have time. Thank you very much for an insightful talk. So does anyone have questions to the presentation?
if not, I'll be here this evening and I'll be here later. So you can anyway talk to me or ask me any questions you have. Would be very interested. There is one question.
Hi, thank you for your presentation. I have a question. If this whole, maybe it's off topic, but a little bit off topic, but if this whole infrastructure is scaling ever more and more, is it growing exponentially or is it growing more linear, the whole internet story, let's call it like this?
I would think it is especially the internet is growing kind of linear meanwhile, because it has achieved a pretty much maturity level. But what is growing exponentially, and we also have reports on that. We have a global interconnection index, which shows that especially the private interconnection between parties to exactly exchange data for AI analytics use cases, that is actually growing exponentially. So the public internet infrastructure is kind of linearly growing, but the private interconnection to make more use of one-to-one communications, that is definitely growing exponentially.
Thank you.
And maybe one figure to that, to leave that. So if you study the public press, there's usually very often quotes from the DKIX, the German Internet Exchange, about how much traffic they do per day or per second, which is currently about 13 terabits per second. In a standard interconnection data center, so such as Equinix in Frankfurt, we are seeing or interpolating traffic, which is around 1.3 terabits per second, 1,300 terabits per second, so about the 10 to 20 times amount of the largest internet exchange in the world. That is really the data that is exchanged even past public infrastructures. So if we really want to bring it on a big scale, then we need to think about infrastructure. Thank you very much.